Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal bin Hazri Tauding. My nama matric is CN180145 and my supervisor is Mr. Bacik bin Abu Bakar. Okay, today I want to present about my FYP, final year project, and my title for FYP is the comparative study of gasket thickness in piping system at UTHM Biodiesel plant using finite element analysis. Okay, now I will talk about the introduction. Okay, as we all know that there are several kinds of plant in the world. For example, chemical plant, refinery plant, and petrochemical plant. Okay, this plant is used the pipe to transfer the working fluid such as water, fluid, gas, and liquid from one location to another location. This system, we call it the piping system. Okay, next, the purpose of this project is to study the effectiveness and thickness of gasket between flange in the piping system to reduce the cost of the production. Okay, gasket is a very important thing in the piping system. The function of the gasket is not only provide a seal, but it also to prevent liquid from escape, and it is important for the safety device. Okay, now I will talk about the objective for this project. There are three objectives for this project. First, to compare the bond stress, displacement, and equivalent strain of the gasket thickness in the piping system. Second is to study gasket thickness in the piping system using a simulation technique. And lastly is to predict the mechanical properties of the gasket to reduce the operation and maintenance cost. Okay, for the problem statement, at the plant there are many equipment such as pump, boiler, tower, cool tower. Okay, during the startup process, there are pressure. So during the pressure, the different pressure when start up the process, it can make the equipment damage. Okay, beside that, the gasket between the flange also can be damaged, and if the gasket is damaged, it can make the piping system not work properly due to leaks. Okay, instead of experimental study, better study with the simulation method to save time, to save main cost, manpower, and safety. Okay, next, I will talk about the scope for this project. This project is using the carbon steel pipe, and the code for carbon steel pipe is SDM A106. The working fluid for this piping system is water, and I use the SolidWorks software version 2020 to make the simulation. Next is the material of gasket. I use the rubber that is Nippon rubber, and the code for the non-metallic rubber is ASME B16.21. The pressure for this project is 4 bar or 58.0151 psi. The pressure is from the suction of the pump. So the next is the gasket thickness that I will be studying is 1 mm, 2 mm, 5 mm, and 8 mm. The pipe size for this project is 4 inch, and for the flange I use the raised face. Okay, so this is the methodology. First type, second the project title selection, find the article and journal, select material. Okay, for the cell material, I use two type of material. There is rubber and the carbon steel. Okay, next I have to fabricate a 3D model. Alright, 3D model, there are 4 parts that I have to fabricate. Pipe, elbow, flange and gasket. After complete the part I have to make an assemble, and after complete the assemble I will do the simulation to testing and analysis. After that I have to do the report and summarize it, and lastly I can submit it to the panel and the supervisor. Okay, next is the methodology. So for the methodology, first I have to fabricate the 3D model. I use the software SolidWorks version 2020. 4 parts that I have to fabricate: pipe, elbow, flange, and gasket. All these pipe, the material is carbon steel, except for the gasket. For the gasket, I use the rubber. Okay, next, simulation. Okay, there are 2 simulation that can do from SolidWorks software version 2020. That is CFD and FEA. FEA stands for Finite Element Analysis. Finite element analysis is mostly about to study or to analysis the static pressure, or yes, the static pressure. From the analysis, I can got the result for volume stress, displacement, and equivalent strain. Okay, these are the example, the part that I have fabricate: pipe, there's elbow, flange, and gasket. Okay, next I will talk about the result and the discussion. As we can see here, the table show that the maximum and minimum for every result: volume stress, displacement, and equivalent strain. Okay, from that I can conclude that 8mm gasket has the highest volume stress and displacement, while the 1mm gasket has the highest equivalent strain. The factor that 8mm gasket has the higher volume stress and displacement because of the pressure that applied to it. Alright, the 1mm gasket has the highest equivalent strain because the thinness of the gasket can make the rubber or the gasket to be pulled. Okay, to be pulled, so it make the strain more increase. As we all know that rubber is a soft material and it is easy to strain, but rubber material is very good to be used in the piping system that flow water as the working fluid. Okay, next I will talk about the conclusion and recommendation. So gasket is very important seal in the piping system. If an inappropriate type of gasket is used, it can cause the serious problem for the system. In selecting the gasket, it is important to evaluate the process, fluid pressure, and the temperature. Okay, the analysis is very helpful in this project because it can help to determine what gasket is suitable for use in the piping system. Okay, the result from the analysis can show that critical part of the gasket during the process. So from the conclusion, 8mm gasket are the best gasket and can be used in the piping system because they have high pressure resistance. This is my recommendation. At the end of the project, there are several lags and certain things that need to be improved for the better result. There are two recommendations might be useful. First, students should get hands-on experience by doing the maintenance at Biodiesel plant UTHM. Second is use the ANSI software to analyze the gasket because ANSI software is more detailed about the flow in the piping. I don't say that SolidWorks is not good, but use the ANSI software is better. You can get the better result and more right for the gasket. Alright, okay, that's all from me. Thank you.